stained glass window that measures 2 feet by 1 feet. You have 4 square feet of glass with which to make a border of uniform width. We've run into that phrase before. Back in our note packet, we did a problem about a quilt. So we're going to make a border of uniform width around this window. What should the width of the border be? So I always like to start my geometry problems with a diagram. So let's go ahead and do that. We're going to go ahead and make a window, stained glass window. And this window is 2 feet by 1 foot on the other side. You are asked to make a border around this particular glass window, but that border should be the same width all the way around. So when you go to add the border, for instance, on this side here, I'm just going to draw a border here, right? We're going to want to add on a distance here, and that same distance, and we don't know what that distance is, that same distance up top. Furthermore, you want this border to go the whole way around. So what we're doing, I'm just going to clean this up just a smidge, is we are adding on a border the whole way around this particular window. And that unknown length that we're adding on each time is x. So if I add this border to the top and bottom and the sides, I'm adding on x each time. So if I connect these, what we see is that I have a border. I tried to make it as scale as I could, but I've added on x in all directions. So the original square footage of my window is just 2 by 1. So that's 2 square feet for the window. But now I have on this border, right? So it's helpful then to think about what the width of that border should be as our x value. So x is going to be the width of the border. Now, do you see what I did here? I just drew another rectangle around the rectangle I already had for the window. So what I'm going to do is I'm going to identify this new length and this new height, or this new width. So if the original window was in here, and that was 2 feet by 1 foot, and I added an x on either side, so I added an x over here, I added an x over here, we could say that that new length is now 2 plus the x that's on the left side plus the x that's on the right side. But no Algebra 2 kid is going to leave an expression that looks like that. Combine your like terms, that new length is going to be just 2x's plus 2. Okay, then we can look at the new height of our window. So originally this was just 1 foot tall, but I had to add an x onto the top and an x onto the bottom. So this new height might be x plus 1, but no Algebra 2 kid is going to leave that. Combine your like terms, we have 2x plus 1. So your new length is 2x plus 2. Your new width is 2x plus 1. What I'm starting to build right now, or what I hear myself saying, is that I could take my new length, or my new width, however you want to look at it, times my new length, and I would get my new area. So we got to think about what the new area is, right? Well, if the original area of the picture was just 2 square feet, and it says I have 4 square feet of glass to build the border, my new area is just going to be the sum of 2 and 4. So the sum of 2 and 4 is 6. And then I have my new width. My new width was just that 2x plus 1. And my new length was just that 2x plus 2. So I can go ahead and bring those down, and what I get is a really nice quadratic equation that I can go ahead and solve, which I'm going to go ahead and do that. So again, I would go ahead and just start to FOIL through that one side there. So if I FOIL this left-hand side, I got 4x squared plus 6x plus 2, and then that's equal to 6. I can't really solve this unless I get one side equal to 0 using, factoring or the quadratic formula. So if I subtract 6 from both sides, I get 4x squared plus 6x minus 4 equals 0. I can take a GCF out of there, so that'll be 2. And then I have 2x squared plus 3x minus 2 equals 0. And then you would take a second to AC group. AC grouping leaves us 2 times 2x minus 1 times x plus 2 equals 0. I then have to ZPP, so I get 2x minus 1 equals 0, and then x plus 2 equals 0. And if I add 1 to both sides and divide by 2, I get x equals a half. Subtract 2 from both sides, you get x equals negative 2. We would never add on a border that has a negative length, so our answer for x in this case is 1/2 of a foot, or 6 inches. So you would go ahead and jot that sentence down. What I wanted to go ahead and take a quick opportunity to show you is just how you could verify this again on your calculator. So I am going to go ahead and do that with you here for a moment. And what you're going to see on the right side of my screen is sort of a different approach. I did actually type this equation here, 4x squared plus 6x plus 2 equals 6, into my graphing calculator. And I just wanted to remind you that whenever we solve for x in algebra class, we're just trying to find the values of x that make this a true statement. In other words, we're trying to figure out when does the left side of the graph run into the right side of the graph. So that's what I went ahead and I did. In my y1, you'll see I typed in 4x squared plus 6x plus 2. And then in y2, I typed in 6. And then this is these are nice numbers here, so Zoom Standard worked just fine for me. And you see that this parabola runs into the line y equals 6 in 2 spots. That's how I get 2 solutions. So I have this U-shaped graph running into that red line in 2 spots. And I can just calculate the point of intersection. So I can go down to option 5 this time around. And I'm just going to verify the solution was a half. I'll get close to it. Press enter, and then enter again, and enter one more time. And you see that we do get an x value of 0.5 when our y value is 6. So that is the solution to our problem. So instead of finding the zeros, I just found where the left side of the graph runs in, or I'm sorry, left side of the equal sign just runs into or intersects the right side of the equal sign. Super convenient and also very easy to do. You could have, just to be clear, just type this equation into your calculator and found the zeros as well. But you folks can handle the truth. So you're super smart. So I just wanted to show you a little different take on the problem. And that wraps up that guy for us. And I'm just going to go ahead and pause my video here. And we'll make you something else for a couple more